Well, good morning. You all are the hearty souls, bright and early here on Sunday after the big gala. So thank you for such perky smiles and bright eyes out there. Exactly. It's a pleasure to be here. Really interesting times, very dynamic, I think is an understatement. But, I think in all that, we also have an equal amount of opportunity. And so I'd like to talk a little bit about that this morning. When Amanda said, hey, we'd like to talk to you about why explore, why humans, what destinations, and how are we going to make that all happen. So that's kind of the theme and tone and tenor of what I'd like to touch on today. And so without further ado, let's see. So am I the clicker? Okay, sorry. All right, good. So I have control. I need to tell my wife that. I think it's the other way around. Anyways, why do we explore? I think this conference in particular is so laser crisp in focusing on that. But as we look at the benefits to civilization, and we look at it's broadening. It's a very human in some ways innate, some ways spiritual. But as we look to broaden our experience and leverage our imaginations, not only looking at increasing our understanding of where we live and our environment and those surroundings and the potential threats there, looking at expanding our economic well-being, looking at the intellectual and emotional drivers behind that. But it's also about, and it's very appropriate to today and the times that we live in, looking at how we can be more efficient and more effective in leveraging the scarce resources and living within the constraints that we have. But it also pushes us to necessity is the mother of invention, definitely, but it focuses us on those challenging tasks that must be overcome in order to succeed. And I think a compelling driver like space exploration and human space exploration at that is truly a worthy challenge. But it's also about excitement and inspiration. I think each and every one of us has some story, some compelling reason why we became space junkies and it became so focused on this field. And so I think whether that's the intellectual or whether that's the mystery or the challenge or the excitement, whatever it is to you, I think the amalgam of all that is a strong and driving force, and I think that is the key to leveraging the exciting opportunities that we have ahead. So as we look at what uniquely humans bring to the space exploration game beyond the robotic side, certainly our cognition, our ability to quickly identify, recognize, and adapt and respond. Also a measure of dexterity for our apt interactions with the environment. Certainly adaptability, being able to react and respond, and that deductive reasoning and that uniquely human attribute, although certainly as we evolve with our human-robotic interaction, our artificial intelligence, I think the synergies between the two is ever more important. And finally, it's about inspiration, because to have humans engaged, to have an off-planet human presence requires humans by its very nature. And so as we look at kind of 6 general themes, these encapsulate the whole reason, or at least this is the common base plane of referencing that we use to develop our architectural approaches, kind of take our objectives and our strategy and policy drivers and build those down into architectures and systems and then missions and plans from those. But it's about human civilization and scientific knowledge and in a risk build-up approach, leveraging the preparation necessary to expand exploration beyond. Certainly it's about economic expansion. I think that is key to the private sector as well, looking at the benefits and opportunities and return on investment there. But it's also about global partnerships in a peaceful and productive and constructive way, in engaging the public, not only through education, but also inspiring the next generation of folks to follow, folks to push the bounds ever further. And so this is not only what we use within NASA, this is actually the common binding element that we use to discuss on our international agency-to-agency cross dialogues as well. Now, as we look at this opportunity, and as we look at this new human space exploration enterprise, affordability and sustainability are key drivers in that. As part of the go forward plan for the president coming. The International Space Station is going to be a key part of that, extending its operations to at least 2020, certifying it for beyond, and leveraging it from a utilization perspective to the full extent of its capabilities. As we look at international partnerships and commercial and academic and industry and other government agencies, I think the bottom line is increased partnerships opportunities are not only important, but they're essential. They're critical to our success. And in so doing, engaging the public, not just as observers, but as active developers, active participants, active shapers and refiners, that is here to stay, and is only going to amp up more. Working to reduce both the fixed and recurring costs is vitally important. There's just not enough money to go around. And working with the commercial crew and cargo industry, certainly to LEO, and looking beyond as we shape and evolve. That's a fundamental premise of the new go forward plan. And in so doing, it's not just focusing on one destination, it's bringing them all into focus. And that could be LEO, HEO, GEO, cislunar, Moon, Mars moons, NEOs, and beyond. So I think that presents not only an opportunity, but also a challenge as we look for capabilities that can be cross-leveraged. So that's a key element going forward. And finally, we already talked about reducing system costs, but by leveraging the best and brightest from not only traditional space sectors, but across the portfolio. And I think that's going to be vitally important as we move forward. So here's NASA's exploration vector. As we've already talked about, extending human presence throughout the solar system, and doing so at multiple destinations, as we've discussed. It's about creating new knowledge and capabilities to do so, and doing so over the short, medium, and long term. Sharing that through science, technology, engineering, and mathematics education, and public outreach, and participatory exploration. And then also looking at expanding the trade space, looking at the options and alternatives that we can leverage. And I think a cross-cutting theme throughout that is people and a strong vision and a follow-through on that vision are the most important elements for success. So how are we doing that? How are we looking at this macro challenge to enable humans beyond low Earth orbit? Well, certainly we have the destinations of interest, but as we look in a strategic sense, what needed capabilities are there, and what precursor knowledge or what kind of robotic elements or build-up elements do we need? As you look at those in totality, that's how we're leveraging our planning and our systems definition. So as we look at HEFT is the Human Exploration Framework Team. That's been a cross-cutting agency group that has been focusing on the challenge of multiple destinations, some of the constraints in our stakeholders, and looking at what kind of capabilities are going to be needed to go forward. So I think as we start to roll out some of the products of that past several months of work, I think you'll see that there's been a lot of good, comprehensive, well-considered thought going into our planning. So as we look at these multiple destinations, certainly as we expand out the challenges and the capabilities that we need expand, not necessarily linearly, but perhaps on a little steeper curve. So first off, leveraging the International Space Station is vitally important, and that means opening it up not only to traditional space agency players, but non-traditional. And and students in industry and fully leveraging its capabilities. So I think that's vitally important. But likewise, in space, both Earth orbit could be LEO, HEO, GEO, or the Lagrange points, Earth, Sun, Earth, Moon. Why those destinations? Well, essentially, there's already a lot of infrastructure, certainly at GEO and LEO, and they do provide some unique vantage points. But servicing, refueling, maintenance and repair, orbital debris mitigation are all elements that I think are going to be certainly amplified in the near term. Likewise, we're also able to leverage our partnerships with other agencies, and I think from a commercial sense, there's a huge potential for opportunity there. But here's some of the challenges, and you'll see that these, as we walk through an increasing difficulty, the challenges list get a little bit more extensive. But a common thread throughout is low-cost access to space. But as we look at getting out in and beyond the Van Allen radiation belt, certainly radiation protection is a key driver. And as we look at the Solar Max coming up, I think we're, as we look at the challenges beyond for both SPE and galactic cosmic rays, those are key challenges for humans that we must tackle consistently and pervasively. Likewise, as we look at prop storage and transfer, automated rendezvous and docking, power gen and storage, advanced robotics and avionics, these are all going to be common themes that we carry forward and across. Precursor missions, as we discussed, in order to obtain the critical information that we're going to need to reduce risk of human exploration, sending robotic precursors to these challenging and exciting locations is important. It's also much more cost effective, and I think it builds in an inherent element of risk reduction. But balancing that in a cost-constrained environment requires us to think out of the box and be a little bit more creative, perhaps, than we have in the past. Some of the near-term missions, as envisioned, are looking at the moon and also perhaps looking at ISRU, in situ resource utilization, to see about the utility and efficacy of leveraging resources and living off the land, if you will. Another example is analogs. This is a community of doers here, and I think analogs are emblematic of for huge benefit. Build a little, test a little, leveraging the operational environment to wring out true challenges and poke out the weaknesses in some of our requirements or some of our thoughts or designs, or actually separate the chaff from the wheat and know where to better invest early on. And I think these environments have been great for not only training but partnerships and student-public engagement. So we're going to continue those on, but with a diversity that matches our destinations as well. Now, the moon. Why the moon? Well, certainly it's part of our culture. Much shorter to get there than Mars. 3 days out, 3.5 days back, versus a year plus trip. I think it's a vital element to risk reduction for a future planetary mission beyond that's much more challenging. With the resources that continue to be discovered and unfolded there, I think there's a huge potential in the moon. From a scientific perspective, as my next slide will show, it's been a phenomenal year, and I think the mysteries that we continue to unravel with LRO and LCROSS and some of the other international missions are really compelling. But as we look at the need to amplify and build up our capabilities, certainly here the challenge, the list of challenges is much greater as we pull in the surface capabilities, the entry and access away out of the gravity well, albeit 1/6 G on the moon. All of those, and as we amplify the mission, so too does the environmental control and life support system capability that we need there on the moon. So here's just a quick smattering of some of the really phenomenal, cool picks and discoveries out of the Lunar Reconnaissance Orbiter. So first off, the coldest place in the solar system, roughly, I believe, 40 Kelvin, looking looking at, yes, indeed, it wasn't faked. There's the first steps on the moon from Apollo 11. You got Apollo 14, and for those of you who know the history, due to a slight navigation error, they actually they had the near miss of Cone Crater. We found the Lukinod 1 rover, the Russians lost rover. Got some phenomenal captures of the far side of the moon, the points of eternal light down at the South Pole, the deep lunar pits, and also the channel. So I mean, what an exciting time on our near peer friend in the close environment of Earth here. Now, near-Earth objects, huge focus. President came out and said we'll do a near-Earth object mission in 2025 on the 15th of April. Why? Well, they do have some exciting mission and scientific interest, certainly as they are part of a build-up approach of increasing complexity and increasing capability required. Fairly longer duration, but we don't have to delve into the deep gravity well. So they present both options and opportunities, but also challenges given the microgravity environment and some of the unique characterization that we have yet to do, not only in looking at the types and amounts and quantities, but also the variance within those and our challenges of you don't really land on a NEO, you kind of dock or grapple or kind of loose formation fly, if you will. And so I think as we look at the challenges of those, plus looking at the planetary defense side of the house, learning about the capabilities that may unfold and be important to leverage as we see that our environment here on the Earth is fairly fragile, and having that kind of knowledge and capability may be vitally important in the future. But again, many of the same challenges as we saw in the moon, but also some different ones. Just kind of putting it in perspective. So there's the Orion, and these are true to size. As you see, the fully completed International Space Station there at about 110 meters, roughly a football field, compared to the asteroid Itokawa that the Japanese Hayabusa mission recently returned. And then you see the Orion crew capsule. So it is truly there's a full range of near-Earth objects, sizing and challenging, but I think that's going to be exciting going forward. As we look at Mars Moon, as the environments of Mars, whether it be Phobos or Deimos, no large gravity well, and perhaps we could leverage some teleoperation of robots, but there are some exciting challenges there. It is a fair amount of risk reduction, but going all the way to Mars is challenging, particularly from a radiation perspective. It will push us, not only from a science and exploration perspective, but I think that would also lend a strong sense of inspiration and excitement here on the globe. And then finally, as we look at Mars, why Mars? Well, searching for life or understanding our climate changes or the geology or geophysical characteristics, or living on another planet. And I think this one, not only with the discoveries in the near past, but also the opportunities there, I think that holds true promise as one of the ultimate near human exploration destinations within the relative near time of decades. And so the challenges there, daunting, but nevertheless, I believe it viable in the forward look. So, wrapping it up, we've been we look at the potential destinations, look at these common capabilities to address the common challenges, and then we look at what technologies are necessary to develop or refine or produce those capabilities, and that's how we prioritize not only our planning, our budgeting, our spending, but also the mission build-up work going forward. This kind of puts it all in perspective for each of the broad classifications for in space, Moon, NEO, Moon, Mars. environment and Mars for each of those capabilities. And so, and these slides are all going to be available, so I apologize for going so quick, but I just kind of wanted to give the broad snapshot. As we look at needing to be more sustainable and affordable, certainly reducing mass and life cycle costs adds to that. And we're trying to identify and put in a hierarchical or prioritized sense those key long pole in the tent capabilities that we need to be investing in for the benefit of not only NASA but across the nation, across the global community in meeting these challenging objectives. And of course, as we look at the technology development for space, as we touched on, there's a huge amount of terrestrial benefit, not only in energy and transportation and health and environmental and economic and educational pursuits, but I think across the board. And so this is part of the message of sustainability. And so we take a little bit of our space technology program, our innovative approaches, look at the destinations, looking at our technology development and demonstrations, our analogs. We all roll those up, driven by the themes, and build our design reference missions. And so that's how we take that approach in a holistic sense, both human and robotic, leveraging all the capabilities that we have and building a strong roadmap going forward. And so as we look at this path, this new space path, we're focusing on, we saw access to space, low-cost access to space as being a big driver. So we're looking at heavy lift and propulsion technology. We're looking at flagship technology demonstrations, bridging that technology readiness level from 1 to 6, then rolling it into the 7, 8, and 9, where it can roll into the programmatics at lower cost, lower programmatic risk. We're also looking at investing in smart technologies in our exploration technology development demonstration area. Likewise, for exploration precursor robotics, we're focusing those on the key knowledge and insight that we need to scout for and send in humans. And of course, we look at human research as being being kind of one of those long poles. The pink matter out there is perhaps some of the most challenging. And finally, commercial crew, that's a key tenet as we look at leveraging in a cost-constrained environment this phenomenal engine of innovation and economic capability that we have in the United States and abroad. Commercial crew and cargo is going to be a vital element of that, and I think that's a cornerstone of the President's policy and agenda as well. So here's just some quick snapshots, pictures worth 1,000 words, looking at sensors and other capabilities for landing and hazard avoidance, looking at heat shield technology development, returning from NEOs and the moon is a stressor and is challenging, and so I think those are key investments. Likewise, as we touched on, in situ resource utilization, learning how to live off the land, learning how to leverage both the moon, NEO and Mars unique resources and capabilities is pretty important. And then we also talked about that environmental control and life support systems. As we look at reduce, reuse, recycle, regen, that is no different for our controls of our atmospheres and the environment for these longer duration missions. You just can't afford to take it with you if you're going out for a year. You got to have closed or darn near closed systems. Likewise, we talked about the human research program, looking at the effects of fractional gravity or microgravity, or looking at the extended radiation exposure. All those are going to be stressors, and looking at the human and the human factors and the behavioral elements of living in such close environments and closed ones for such a long time. But as we build, this is how we're kind of attacking it. First, there we go. As we look to build in a phased development perspective, we're looking to leverage the commercial sector, our robotic precursors, and look for those key technology investments. Then build a little, test a little design, and test in analogs and leverage ISS and refine our heavy lift and in-space capabilities. And finally, leverage them for human space exploration across the portfolio. This already is subject to change, but this is just kind of a quick snapshot of how for each of those functional areas that roadmap all plays together in a time phase fashion. And of course, intrinsic in that is across NASA, whether it be Bobby Braun's Office of the Chief Technologist or in the mission directorates, whether it be science or exploration missions, building together with a little bit of technology push and pull, and certainly prioritizing to these mission needs is how we're doing that. We're also leveraging commercial crew and cargo. It is a vital element, and I think for the first time in history, we've seen that true opportunity readily unfold with successes that are just the first in a string of more. We talked about partnerships. Certainly international. We're playing with 14 other agencies in the International Space Exploration Coordination Group, but we're also leveraging a lot of non-traditional players, folks in Africa and the Middle East and South America much more prevalently. From the commercial side, both traditional and non-traditional, NewSpace, other government agencies, academia and technology, and these are all driven by our national space policy. And so I think I think the word of the day is cooperation and collaboration are vitally important, and they're here to stay. This just gives you kind of a snapshot of some of those 14 nations that we're working with, and we're also in creating a long-term vision, developing a global exploration roadmap that identifies common areas, leverages our International Space Station investments, but also looks particularly in the precursor robotics and the flagship technology demonstrations areas for those joint or cooperative or collaborative opportunities with our international partners and friends that will make this not only more affordable but sustainable and build on the richness of the intellectual diversity. From an involvement or engagement, I mean, NASA has 4 primary big tenets. That's inspiring and engaging and educating and employing. And if you look at those across the spectrum, that's the key as we see an aging in our workforce demographic, as we see an increasingly agile set of mission demands and drivers. It's important that we leverage and we harness that diversity in our NASA programs, and doing so, engaging the public, not in a passive sense, but in an active sense, leveraging all the tools out there, but also being driven by that huge crowdsourcing, that huge broad-based public engine of innovation. And so, summarizing it all together, essentially, our new space exploration strategy is about exploring not just one destination, but many, and opening up that frontier and aligning it with our national priorities, improving our economy and contributing not only to international but all partnerships across the board. It's inspiring young folks, middle-aged folks, and old folks alike, and providing the change. Providing the change to NASA to make us relevant, affordable, sustainable, viable, and robust in the future. And so we're looking to extend to that human presence, not so different, not so different from the past, but we're looking to extend that to multiple destinations, building the knowledge and capabilities and the technical elements necessary along the way, and looking for alternatives to the ways that we've done things to make it more viable. So, in summary, we are definitely launching a new era in human space enterprise, and the real question is, are you on board with that? I think the opportunities are just absolutely exciting, and so thank you very much for having the opportunity to address some of these key options and destinations, and I'd gladly take any questions. I think I got maybe a minute or two, but it looks like we're right on time. So any questions? Yes? Aloha. Hi, Jim. Well, I think in the international sense, we've been seeing we've been seeing the same thing abroad as we see it within the U.S. Is everybody is operating in a cost-constrained environment. So the low-hanging opportunities have almost turned into essential cross-communication. We're seeing folks not having the funds to do things all alone, but rather the collaborative work. We've seen that in analogs. We've seen that in the huge, low-cost, high-payoff environment of analogs. We've been seeing a much greater cross-cooperation. You know, as we look at Soleil 2 and Chandrayaan 2, and as we look at some of the near-term moon missions that are planned, we're looking at hosted and auxiliary payloads and sharing of instruments. That area is very ripe. We're also looking in technology development. We realize that you can't do it all yourself, and so as we look at this broad architecture and we say, hey, you know, from a national interest, we're actually talking and listening rather than dictating. We're saying, hey, you know, Germany, DLR, what are you interested in? Canada, what are you interested in? France, looking at across the board, and then saying, hey, if you guys are going to be working in this area, maybe that's well covered, or you know, as we cooperate and collaborate, that seems to be an area of very fertile ground for us. So as we build this global exploration roadmap, that kind of time phases and syncs everything, so we know when the appropriate time for investments are, when those bilateral and multilateral dialogues need to take place to build those relationships. So that's kind of a quick snapshot answer to that. But certainly, I can tell you that unlike the past, we're looking at international partnerships that may allow key participation on the critical path. We're looking at that being a necessity. And it's not only within the civil space realm. We're looking at it at the DoD intelligence community and commercial space ever more pervasively. So, yeah.
How much do you regard what you might call happiness of the partners with the status and progress of the ISS as critical to getting them to play appropriate roles in human exploration?
Yeah, that's an excellent question. Of course, we're looking at the International Space Station, 5 partners, 16 loose associates, and we're trying to identify, you know, as we extend the International Space Station, so too does that carry cost with it, and those costs actually come at a cost of not being able to, by investing in ISS, they don't have quite as much in a zero-sum game available for exploration, and so. Amen, and that's exactly what we're looking at. We've taken the ISS lessons learned from the Multilateral Control Board, and we're looking at the technologies going forward, and we're saying, hey, how can we leverage ISS for exploration benefit much more fully? How can we leverage the partnerships that we have ingrained? I mean, we've even looked at some crazy stuff like, you know, as you get to the end of the lifetime of ISS, why not leverage some of those components instead of taking it apart and deorbiting? Why not leverage some of those for a NEO mission, or why not put ISS at EML1? Or you know, as we look at some of those opportunities, that's absolutely what we're doing. We're looking to say, hey, how can we do this more efficiently? Use those partnerships, but at the same time, we also learned some better ways of doing things than ISS, and we learned that it is a fairly exclusive club, and there's a lot of folks who want to play who don't have access. So we're looking at co-PI activities, getting, for example, we've been dialoguing with South Korea and the Koreans working with them because they have some strong interest, and so that's just a little snapshot into how we're playing in that area. Yeah.
Great investment that NASA has put into buying down mission risk systematically, and you do that through technology investments. What keeps the cruise missile that keeps taking down these architectures is, I'm going to call it program risk. What kind of investment is NASA putting into buying down program risk? Because that's the one that's always knocking you guys out of the game.
Yeah, I don't disagree with you at all. I think if you look at the cost schedule, technical, you know, the big 3 that always roll up any program manager's risk posture, and as we look at, I don't think we've done a good enough job at looking at the ilities in the operability, driving down the life cycle costs, looking at the full life cycle phasing. I think we need to better leverage those investments. I think we need to reduce as we look at the insight oversight models, I think we're heavy there. I think we definitely need to look at some leaning. And I think the neat part is as we've gone through and looked at the commercial crew and cargo, as we looked at challenging our existing paradigms, I think there's a growing groundswell of folks who say we absolutely must change to evolve with the environment. We got to look at our infrastructure. We're carrying a huge amount of infrastructure, and our deferred maintenance and our lack or lower ute rates for some of those things are really challenging. So it's a broad programmatic look, and it's one that we're trying to tackle. But as any large bureaucracy, that is an effort that takes time. We're trying to be much more catalytic, much more transformational on a short term. That is a key thrust of some of the leadership, some of the policies. I think that's some external stimulus and some internal as well. So I think right now we're at an inflection point where, better than any other time, we have not only the need, but also perhaps the spirit to make those changes. But it's a narrow window, and I think if we don't, pragmatically, we're going to end up in the same place. And so I think that ought to be enough of a forcing function to get us there. But it's all about people too. I mean, this big system, this big NASA, there's a couple of key change agents, there's a couple of key people, but we certainly are open, as we must be, to new ideas and to input. If you're not, well, you're dead in today's world. It's just too dynamic. So more. Yes.
Hi, John. My name's Walter. So according to your time and the flow charts up there for some of these missions in the future, if NASA isn't going to be running some of these longer-term missions until 2015, 2025, when do you think the next real need for an astronaut class is going to be? Or is that going to be pretty far out? As somebody who might be interested in doing that down the line.
Yeah, that's another good question. So right now, I think with the last class, they knew that they were not going to fly in the space shuttle. They were brought in. Knowing that they're going to be explorers of a different variety, and so that's caused us to look at the skill sets. That's caused us to look at the timing. It's no secret that we've had a large atrophy in the astronaut corps because some folks came in for the short duration space flight. As we look at the long duration space flight, and as we look at the budgetary drivers, we may have a gap or a period where, as we look at a crew of 6 on ISS, and we look at having 2 U.S. astronauts there at a time for 6 months of pop. As you look at the nominally 3-year flow of the astronaut training to go through ever more pervasive training, spending the time in Russia, learning the Soyuz systems, learning the Russian segment controls and functions. We're looking at our demographics, our skill mix, our ages, looking at anthropometrics because not everybody's rated for long duration space flight. We then look at these plans, huge amounts of turbulence in there. We look at when our need is for testing of the next systems. We look at who do we need to have selected early in the design, development, test, and evaluation, and carry those experiences, much like we had astronauts in Apollo and Shuttle going through the design and development of the vehicles and then flying them in the early test flights. And then as we look at getting out of more the taxi mode or the up and down to actually doing these construction or these long-term research or exploration missions on the moon or NEOs or Mars, it's in many cases a different type of person, a different type of capability. So to get to the real nub of your question, what's it looking like for the future for astronauts? It's dynamic, just like the situation that we're in. I think the astronaut corps is going to contract further. I think we'll be carrying some on, but if you shut off the pipeline, then it's a dead organization or it's non-vibrant. I think so. We'll be bringing in a kind of a keep alive, but they will definitely have different skills. To those out there who are interested in that, the same rules have always applied. It's a roving dynamic target. Do something that you love, be the best in it, stay healthy, engage be a master of or a jack of all trades, a master of one or two, and I think as we look at not only the government human spaceflight side, but also the commercial spaceflight side, I think there's going to be different opportunities there. I think all the old rules may not any longer apply, but I see that as also an opportunity. Tougher to pick the target, but if anyone has ever just existed or lived to be an astronaut and done what all the checking of the boxes, that can be very unfulfilling, and I don't recommend that path because very few folks do get selected to be astronauts right now. I'd certainly like to change that. I always wanted to be an astronaut. It didn't work out for me, but I think now more than ever we have the potential to open that up much more broadly, and as we discussed, throughout this NewSpace 2010, that's what we'd like to make available to much more to the masses. But I think we're getting there. So I don't have a super duper answer, but at least that gives you a little bit of some perspectives related to that. Any more, or I'm done? Okay. Well, thanks very much. Appreciate it. Thanks, Mike.
Thank you, John. That was excellent. Okay,